So hello everyone, in this video we'll solve another LeetCode problem and the problem name is Maximum Erasure Value. So let us read the problem statement. So you are given an array of positive integers nums and you want to erase a subarray containing unique elements. Now the score you get by erasing the subarray is equal to sum of its elements. Now you need to return the maximum score you can get by erasing exactly one subarray. Then they have given the definition of what subarray is. Now what does this question means? Question is simply saying that you are given an array and you need to remove one subarray, and that one subarray should contain unique elements and the sum of subarray should be as max as possible, and you need to return the maximum score or the maximum sum you can get of the subarray. So how to do this or how to solve this problem in the most optimal way? So let us see this first example and try to find some solution out of it. So this is the first example. The array given here is this one and the output we are expected is 17. So let me just write down the entire array: 4, 2, 4, 5 and 6. So this is the array. Now what is one way? Now one way is the brute force approach that generate all the sub array, find the sum and return the maximum sum with all unique elements. Now but this brute force approach would not work, it will give TLE, so this will not work. Now how we can optimize it? Now first understand what our goal is. Our goal is to find the maximum sum as well as that subarray should contain all unique elements. Yes. Now let us consider that we have empty subarray initially. Now to get the maximum sum, what do we do? Obviously we need to insert as many elements as possible, right? Yes. But when we should not insert an element? Only when we have already element that is present inside it. Or in simple words we can say that if we have some duplicate element. In that scenario only we should not insert the elements, otherwise to get the maximum sum we should keep inserting the elements. So this is a kind of sliding window approach that we need to use. Keep on inserting the elements, but when the condition fails, shrink the window. So we will use this sliding window approach to solve this particular problem. So let us see how we can use sliding window in this particular question. So yeah, to maintain the frequency or duplicacy of the elements, we will use map which will be storing like int comma integer, integer comma integer, which will be the number and the frequency count. So first of all, let's say we have the empty map. So when we are our I pointer and j pointer will be initially at the 0th index. Now we will move our j pointer, but before that we will insert the element 4 inside our map. Okay. Now we come across 2. So 2 is also not present in our map till now. So we'll also put 2 with frequency 1 and 4 with frequency 1. This is the map, not the subarray. Subarray will be maintaining here 4, 2. Then we come across this 4 again. Now our 4 is already present in our map with frequency 1. That means we need to now shrink our window. Now we'll be shrinking our window. That means we need to remove 4 and take this 4 into our account. So we'll remove 4. That means this will become 0, frequency 0. And since we are adding this 4, so we will again update its frequency by 1. Now our subarray would look something like this: 2, 4. Now we will again move forward. Now we have 5. So 5 is like not present in our map, so we will insert 5 with frequency 1. Also we will include it in our like subarray as well. And side by side obviously we'll be taking the sum and we'll keep on update with the maximum sum possible. This we will do side by side, and obviously like I'm just showing you the intuition. I'll also show you the code in which I'll tell you how it is being done. But yeah, we'll also add 5 into our subarray. Now we come across 6. Now 6 is also not present in our map, so just add 6 into our map with frequency 1. And yeah, also include in our subarray. So our subarray is ended now. So this is the maximum sum that we'll be getting. So sum is nothing but 2 plus 4 plus 5 plus 6. So that is 10 plus 5 plus 2, that is 17, and 17 was our expected output. So this is how, with the help of sliding window, we'll be solving this problem. So let us understand in more better way with the help of code now. So this is the code. Initially I have declared variable n, which is nothing but the size of nums array. Then I have declared map, which will be telling the number and its corresponding frequency. Then I and j pointer initialized to index 0, sum or the current sum initialized to 0, and the maximum sum or maxi initialized to 0. Then we'll be running the loop until our j pointer goes to the end of the array. Now what was the condition? If we find some duplicate element. If we find some duplicate element, that means we need to shrink our window. Now if we shrink our window, what we need to do? We need to move our I pointer ahead. Yes, but before that we need to decrement that corresponding I value from our sum, also the frequency from our map. Otherwise, if there is no duplicate element present, it is the unique element, then we need to add that particular number to our sum and increment its frequency in our map, and then move forward. Also side by side, just keep updating the maximum sum that we can get. In the end, we just need to return the maximum sum, so we are returning that. So this was the code, and I hope you understand this problem as well. So thank you for watching.